Okay, think about this for a second. We all know what it's like when the power goes out, and you hear that familiar hum of a generator kicking on. But what if the house you needed to power was a floating city, over 300 meters long, that just pulled into a harbor? Yeah, today we're taking that simple idea of a generator and scaling it way, way up. We're going to explore the absolutely incredible engineering it takes to plug a massive ship into a city's power grid. Let's get into it.
All right, so here's our game plan. We'll start with the basics, how we make power whenever we need it. Then we'll look at where these generators, or gensets, pop up in our world. After that, we dive into what I'm calling the floating city problem. And of course, we'll check out the brilliant solution for plugging in a ship, and wrap it all up with the supercritical engineering that keeps the whole thing from going boom.
So, first things first, making power on demand. This is all about the magic of creating electricity right where you are, exactly when you need it. You know the feeling, right? The lights flicker, then nothing. The buzz from all your electronics just vanishes. And in that sudden, kind of weird silence, you realize just how much you rely on electricity. For so many people, this is the moment the humble generator steps up to be the hero of the day. So what is this thing, really? Well, we call it a generator set, or genset for short. Think of it like a personal power plant. It takes fuel, uses an engine to turn that fuel into motion, mechanical energy, and then, through a cool physics principle called electromagnetic induction, it transforms that spinning motion into electricity. It's that simple and that brilliant.
Let's break it down into 4 simple steps. Step 1, the engine burns fuel, which makes stuff spin. Step 2, that spinning motion turns something called an alternator. Step 3, the alternator's movement is what actually creates or induces the electrical current. And finally, step 4, a voltage regulator makes sure the electricity is nice and steady so it doesn't toast your laptop. Engine, alternator, induction, regulation. Boom, you've got power.
Okay, so we know how they work, but where do we actually find them? Well, it turns out these incredibly versatile power boxes are pretty much everywhere, quietly humming away in the background, making sure our world doesn't stop. And believe me, there's a genset for just about every need you can imagine. You can categorize them by what they eat: diesel, natural gas, you name it. You can sort them by their job. Is it a backup for emergencies, the main power for a remote cabin, or a portable one you can haul to a job site? And you can even categorize them by their design, from a loud, open frame to a super quiet, soundproof box. And this is where their importance really hits home. Yeah, they're great for keeping your lights on at home, they're crucial for businesses and data centers that can't afford to go dark, but think about this. In hospitals, they are the literal lifeline. They power the life support machines that keep people alive when the grid goes down. So yeah, our modern world is built on these things, more than we probably realize. Okay, time for a massive jump in scale. Forget that generator in your neighbor's backyard. We are now talking about the power needs of a skyscraper, except this skyscraper is floating in the middle of a harbor. Welcome to the floating city problem. Just to give you an idea of the scale we're dealing with, over 300 meters. That's longer than 3 football fields laid end to end. This isn't just a boat, it's a mobile city with its own lights, HVAC, computers, refrigerated containers, all of which demand an insane amount of power, even when it's just sitting at the dock. And that brings us to the big question, right? What happens when this massive floating city pulls into port? It can't just power everything down. There's a crew on board, cargo that needs to stay cold, and all kinds of systems that have to stay online. So, how do you power it? Well, for a long, long time, the answer was pretty simple. Just keep the ship's own giant diesel engines running 24/7. But that creates a huge problem. It's basically like parking a diesel belching factory right on the waterfront, pumping out fumes and a constant deafening roar. For the people living in those port cities, it's a nightmare of air and noise pollution. So there has to be a better way, and there is. This brings us to our next section, plugging in the ship. We're talking about a concept called cold ironing, which is, without a doubt, the world's biggest and most sophisticated extension cord. The official name for it is cold ironing, or shore power. The idea is brilliant in its simplicity. You connect the ship to the local power grid on shore. This lets the ship shut down its own engines completely, letting the massive blocks of iron in the engine room go cold. A simple idea, right? But making it happen is a whole other story. Here's where it gets really complicated.
A ship's power system and the city's power grid are like two totally different animals. They speak different electrical languages. For example, they often run on different frequencies, maybe 60 hertz on the ship and 50 hertz on shore. The ship is its own little island of power, while the shore is part of a gigantic interconnected grid. They even have totally different safety rules for grounding. You can't just stick a plug in a socket. It would be a disaster.
To make this connection work, you need some seriously clever hardware. First, you need a dedicated substation that creates something called galvanic isolation, basically an electrical air gap that acts like a firewall, so a problem on the ship doesn't take down the city's grid. Then you need a frequency converter, which is like a universal translator for electricity, making sure the power is exactly what the ship needs. And finally, you need these absolutely massive, rugged cables and plugs built to handle insane voltages in a salty, corrosive marine environment. And all of that brings us to our final and maybe most important section, engineering electrical safety. This is all about why you can't just use a normal plug and how engineers prevent these two gigantic power systems from causing a catastrophic failure. This quote really says it all. The number one non-negotiable rule is isolation. You have to build an electrical fortress wall between the ship and the shore. That way, if something goes wrong on one side, like a short circuit, it can't jump across and cause chaos on the other. So how do you build that fortress? It's all about safety by design. We've talked about galvanic isolation. Engineers also use things like a neutral grounding resistor, which is kind of like a giant electrical shock absorber. They run intense fault current analysis to stress test every single component for the absolute worst case scenario. And they even manage something called harmonics, which is like electrical static or noise, to keep the power clean for both the ship and the shore.
But you know, all the best engineering in the world doesn't mean a thing without a rock-solid procedure. Plugging in a ship is a careful, step-by-step dance. Technicians test everything before they even think about connecting. They verify every protective setting. The connection itself is only done by highly trained pros using strict checklists. And once it's connected, the system is monitored every single second, with big red emergency stop buttons ready to go. So when you step back, it's pretty cool. We've gone from the familiar hum of a home generator in a blackout all the way to this silent, incredibly complex system that powers a floating city. But at the end of the day, it's all about the same core principle, taking the wild, immense power of electricity and taming it, controlling it, so it works for us safely and reliably. And that kind of leaves you with one last thought. We've just peeled back the curtain on one of these massive, hidden electrical systems. It really makes you wonder, doesn't it? What other amazing feats of engineering are out there, hiding in plain sight, quietly making our modern world possible?